Hi viewers, welcome you all to this session. In this session, I am going to explain Border Gateway Protocol BGP. One inter-domain exterior routing protocol is usually chosen to handle routing between autonomous systems, that is Border Gateway Protocol BGP. BGP is an implementation of Path Vector Protocol. Initially, a notation was introduced, that is, the Internet is organized as autonomous systems, each of which is under the control of a single administrative entity. A corporation's complex internal network might be a single autonomous system AS has made a network of a single internet service provider ISP. Figure 1 shows a simple network with two autonomous systems. The basic idea behind autonomous systems is to provide an additional way to hierarchically aggregate routing information in a large internet, thus improving scalability. We can now divide the routing problem into two parts: routing within a single autonomous system and routing between autonomous systems. So routing within a single autonomous system is intra-domain. Routing between autonomous system is inter-domain. Since another name for autonomous systems in the internet is routing domains, we refer to the two parts of the routing problem as inter-domain routing and intra-domain routing. Okay. Route propagation. In addition to improving scalability, the autonomous system AS model decouples the intra-domain routing that takes place in one autonomous system from that taking place in another. Thus, each autonomous system AS can run whatever intra-domain routing protocols it chooses. Okay, so now you can see here EGP, that is Exterior Gateway Protocols. There have been two major inter-domain routing protocols in the history of Internet. The first was the Exterior Gateway Protocol EGP, which had a number of limitations. Perhaps the most severe of which was that it constrained the topology of the internet rather significantly. So the replacement for EGP is the Border Gateway Protocol, BGP. which is in its fourth version. So Border Gateway Protocol BGP is often regarded as one of the more complex parts of the internet. Okay. So here we can have a comparison between EGP, Exterior Gateway Protocol, and BGP, Border Gateway Protocol. Exterior Gateway Protocol, EGP, forced a tree-like topology onto the internet. EGP did not allow for the topology to become general. These are the fundamentals of the EGP. Tree-like structure, there is a single backbone and autonomous systems are connected only as the parents and children, not as the peers. Coming to Border Gateway Protocol, BGP, assumes that Internet is an arbitrarily interconnected set of autonomous systems. Of course, today's Internet consists of an interconnection of multiple backbone networks. That is, they are usually called service provider networks, and they are operated by private companies rather than the government. Sites are connected to each other in arbitrary ways. So now you can see here figure 2. Figure 2 gives a simple illustration of the state of the internet in 1990. So figure 2 shows the tree structure of the internet in 1990. Okay. Okay, now here the figure 3. Figure 3 shows a simple multi-provider internet. Simple multi-provider internet. Unlike the simple tree-structured internet shown in the previous figure, that is figure 2, or even the fairly simple picture in figure 3. Today's internet consists of a richly interconnected set of networks, mostly operated by private companies, that is ISP, Internet Service Providers, rather than governments. Many Internet Service Providers, ISPs, autonomous systems. Many Internet Service Provider, you can see the figure 3. Many Internet Service Provider, ISPs, exist mainly to provide service to consumers, that is, individuals with computers in their home, while others offer something more like the old backbone service, interconnecting other providers and sometimes larger corporations. So often many providers arrange to interconnect with each other at a single peering point. Okay. Furthermore, to get a better sense of how we might manage routing among the complex interconnection of autonomous systems. We can start by defining a few terms. Here we define local traffic and transit traffic. So we can define local traffic as traffic that originates at or terminates on nodes within an AS, that is autonomous system. And we can define transit traffic as traffic that passes through an autonomous system AS. Okay. Also, we can classify autonomous systems into three types. So we can classify the autonomous system into three broad types: stuff autonomous system, multi-homed autonomous system, transit autonomous system. The first one, stuff AS. An AS that has only a single connection to one another AS. I repeat again, stuff STUB. Autonomous system is an autonomous system that has only a single connection to one other AS. Such an AS will only carry local traffic. So you can see in the figure 3, a small corporation in the figure. You can see here. So in the figure 3, small corporation. So the small corporation in the figure 3 we can consider as the local traffic. At the same time, multi-homed AS, an AS that connection to more than one other AS but that refuses to carry transit traffic, such as the large corporation given in the figure 3. The third one, transit autonomous system. Transit autonomous system is an autonomous system that has connections to more than one other AS, that is autonomous system, and that is designed to carry both transit and local traffic, such as the backbone providers given in the figure 3, the previous slide. So broadly we can classify autonomous system into three types. So these three types are shown in this slide. Correct? The same figure 3 is given here, but here the autonomous system, the three type of autonomous systems are highlighted. Now you can see that stuff AS, already I told, small corporation. Multi-homed AS, just now I told, it is a large corporation. Then third, backbone service provider, that is backbone service provider is transit. transit AS, right? So already I told there are two type of routing. One is intra-domain routing, another one is inter-domain routing. What is the goal of intra-domain routing? So the main goal of intra-domain routing is to find optimal path between nodes. So the example is shortest path algorithm. At the same time, the goal of inter-domain routing is to find any path to the intended destination that is loop-free. In this case, we are concerned with reachability than optimality. So here reachability is very important rather than optimality. So keep these two goals, separate goals of the intra-domain routing and inter-domain routing respectively. Furthermore, in the context of border gateway protocol, finding path anywhere close to optimal is considered to be a great achievement. Why? So there are additional factors that make inter-domain routing hard. Need to find a loop-free path to destination. Path selected must be compliant with various policies of autonomous systems along the path. So these policies are arbitrarily complex. These are the reasons that make the inter-domain routing hard and complex. So here we can talk about the scalability. An internet backbone router must be able to forward any packet destined anywhere in the internet. Anywhere. Having routing table that will provide match for any valid IP address. 300,000 prefixes in the routing table. Autonomous system choose its own routing protocol and own metrics to assign path cost. But it is impossible to calculate the meaningful path cost for a path that crosses multiple autonomous systems. So definitely there will be issues of trust. Say for example, provider A might be unwilling to believe certain advertisement from the provider B. B might advertise some erroneous routing information. So there is a issue of trust. Okay, now so BGP. So further continuing with the BGP, each autonomous system that participates in border gateway protocol must also have at least one BGP speaker, a router that speaks BGP to other BGP speakers in other autonomous system. It is common to find that border routers are also BGP speakers, but that does not have to be the case. So one BGP speaker that advertises local networks, other reachable networks, that is a transit autonomous system only, and gives path information. So the BGP speaker generally advertises local networks, other reachable networks, and give path information. In addition to the BGP speakers, so the autonomous system has one or more border gateways. What does it mean? The border gateways are the routers through which packets enter and leave the autonomous system. So border gateways are simply the routers through which packets enter and leave the autonomous system. That is, they are simply IP routers that forward packet between autonomous systems. Also, they can act as speakers. Border Gateway Protocol BGP does not belong to either of the two main classes of routing protocols, distance vector and link state protocols. Unlike these protocols, BGP advertises complete paths as an enumerated list of autonomous systems to reach a particular network. It is sometimes called a path vector protocol for this reason. The advertisement of complete paths is necessary to enable the sorts of policy decisions to be made in accordance with the wishes of a particular autonomous system. So it also enables routing loops to be readily detected. Okay. So now we will see an example of network running Border Gateway Protocol BGP. So figure 4 shows an example of a network running BGP. To see how this works, consider the very simple example network in figure 4. Assume that the providers are transit networks while the customer networks are stubs. A BGP speaker for the AS of provider A, that is AS2, would be able to advertise reachability information for each of the network numbers assigned to customers P and Q. Please see the figure 4. Thus, it would say, in effect, the networks 128.96, 192.4.153, 192.4.32, and 192.4.3 can be reached directly from AS2. Correct or not? You can see the figure 4. The backbone network on receiving this advertisement can advertise the networks 128.96, 192.4.153, 192.4.32, and 192.4.3 can be reached along the path AS1, AS2. Similarly, it could advertise the networks 192.12.69, 192.4.54, and 192.4.23 can be reached along the path AS1, AS3. Right? So follow the figure. Based on this figure only, just now I explained. So an important job of BGP is to prevent the establishment of looping paths. This is all I just now explained. Furthermore, here I have highlighted the BGP issues. What are the issues? It should be apparent that AS numbers carried in BGP need to be unique to prevent loops. Also, AS numbers are 16-bit numbers assigned by a central authority. Okay? So, with this, I conclude the session. So, thank you very much for watching this video. So, thank you.